In this video, I will demonstrate how to calculate the displacement vector using arrows. Let's say that we have an object, and at the initial state the object is located here. Now I will choose as my coordinate system to be this one. This is my x, this is my y, and the z direction goes out of the page, and this is the origin, so this is my 0. Now, if this is the initial position of the object, then the position vector in that initial state is shown with this arrow. The tail is at the origin and the tip is at the position. Now, let's say, for example, that the object have moved. After some time, it moved over here to this point. Then the position vector for that final state will be this vector. It has the tail again at the origin, and the tip is at the position. So this will be my R final. This is the final position vector. Okay. Now, I need to find displacement, and displacement is showing us the change in position, the R final minus R initial. So essentially what we have in this case, we have to find the subtraction R final minus R initial. We have to calculate that difference. So displacement is the difference R final minus R initial. Now you can rewrite this as R final plus the minus R initial. So this way we can calculate the difference using addition of the opposite R of R initial. Let's see how this works out. So I have R final, which I'm going to keep, and I also have minus R initial. Now in this picture what I show is R initial. The minus, if this is vector A and you want to find minus A, then minus A is going to be a vector that has roughly the same length. It should have exactly the same length, and it should have the opposite direction. So if that is A, then this is the vector minus A. So minus R initial is going to be a vector that has I'm gonna draw the vector with the tail at the origin. It should have roughly the same length as R initial, and it should have the opposite direction. So it is minus R initial. Now in this picture I'm drawing the length of this to be roughly the same as that. In actually, when you do the calculations, these should be exactly the same magnitude as R initial. Okay. So now I have R initial, this is minus R initial, and what I need to do, I need to add R final and minus R initial. So I have this vector, and I need to add them together. I know that to add vectors, I need to move the tail of one to the tip of the other one. So one way to do it, I could take this vector right here, and I could move it right there, so that I have the tail of minus R initial to the tip of R final. Now what I need to do, I need to add R final and minus R initial. So you can see I have R final, I have minus R initial, and I'm adding them together. And when I add them, start from here, R final plus the minus R initial, I get, I will use a different color this time, I get the vector delta R. This is the displacement vector. So by adding R final and minus R initial, I get the displacement vector. Now I want to talk a little bit about the meaning of displacement. So I said before that displacement is R final minus R initial. Okay, but I can rewrite this expression in a slightly different way. I can say I have R initial plus the displacement. This will give me the final position vector. Okay, so what I did, I moved this term to the left-hand side. So now I have the initial position plus the displacement will give me the final position vector. Let's see. Let's see what this how this is applied over here in this expression. The vector, the displacement vector that I got here, I can move it anywhere in space, and so long as I keep the same direction and the same magnitude, it is the same. It's the same vector. So this is still my displacement vector. Now, this expression is telling us if I have the R initial and I add the change, I should get the final position, which is what we have right here. This is our final position. The initial plus the change is equal to the final position. In other words, a simple example, you can think about this as if you started having two, say you had two chocolate truffles and one of your friends gave you another three, so three is your change, then now you have five chocolate truffles. This is a simple example that illustrates the same thing for vectors.